Okay, so today we will study about the remainder theorem. Now we are going to start our next topic in polynomials. In the previous lecture, we have discussed about the graph of the polynomials, value of the polynomials, and many other terms about the polynomials. Now today we will study about the remainder theorem. So put the heading remainder theorem. Remainder theorem. So now first of all we come to the statement of the remainder theorem. What is the basically remainder theorem? Remainder theorem states that if px be any polynomial of degree greater than or equal to 1, then if we divide this polynomial p of x by x minus a, then the remainder will be equal to p of a. Okay, so first of all we write down the statement of the remainder theorem. What is the remainder theorem? Let p of x be any polynomial greater than of degree greater than or equal to x, greater than or equal to 1, greater than or equal to 1, and a be any real number, and a be any real number, a be any real number. Okay, a be any real number. Then if p of x is divided by x minus a then remainder will given by p of a. Okay, so this is the statement of the remainder theorem. Means if we want to find the remainder of any polynomial, if we divide that polynomial by other polynomial, then remainder theorem helps in this matter. Means if we are given the polynomial p of x which is defined in variable x, and we have to divide it by x minus a, then we have to find the remainder p of a. So first of all let us come to the proof of the remainder theorem. How basically remainder theorem can be proved? So for the proof of the remainder theorem, okay, if we want to prove remainder theorem, basically we all know what is the division algorithm, because for proving the remainder theorem we will use the division algorithm. So basically what is the division algorithm? Division algorithm is given by division algorithm can be written as dividend is equal to divisor, dividend is equal to divisor into quotient plus remainder. This is the division algorithm. Okay, now how can we use the division algorithm to prove the remainder theorem? Okay, basically if suppose our polynomial is p of x, means our polynomial is p of x. Okay, so dividend is equal to p of x. We are dividing this polynomial by divisor x minus a. So x minus a is our divisor, and suppose quotient is equal to q. Okay, plus remainder, suppose I have assumed remainder is equal to r of x. Okay, so by using the division algorithm I have put this equation where px is our dividend and divisor is x minus a and remainder is rx. Now since we know that if division algorithm is true, then the we can write degree of r of x is less than divisor. Okay, this is according to division algorithm. Here what is our divisor? Divisor is x minus a. Okay, now what is the degree of the divisor x minus a? Here the x to highest power is 1. So degree of divisor x minus a is, means we can write degree of x minus a is equal to 1. If degree of x minus a is equal to 1, means what is the degree of Rx? Since degree of R of x is less than divisor, so what is the degree of Rx? Means degree of Rx is 0, or we can say degree of Rx is constant. So we can write degree of Rx is equal to 0, or we can say constant. Okay, if degree of Rx is constant, means we can write R of x is equal to simply R, because R is a constant. So now we come to our division algorithm. P of x is equal to x minus a into quotient plus R. Okay, so this is our equation. Now, if in this equation I substitute x is equal to a in the place of x, if we put x is equal to a in the place of x, so what is the value of p of a? P of a is given by, if I substitute x is equal to a in the place of x, then this quantity becomes 0, because x is equal to a, this quantity becomes 0, and 0 multiplied by q, 0 plus remainder. Okay, so here we can write down P of A is equal to R. So by looking this equation, we can say that remainder is equal to P of A. So this is the remainder theorem. Okay, so it was the proof of the remainder theorem, that if we divide any polynomial P of x by any other polynomial P of x minus a, then remainder is given by P of A is equal to remainder. Okay, so this was the proof of the remainder theorem. This theorem basically used when we have to find the remainder directly. We can find the remainder by using simply long division method, but if we are using the long division method, then we have to divide each and every term, and we have to follow some steps. If we want to find the directly remainder, then we can directly use the remainder theorem. So this theorem helps us in finding the remainders. Now we come to some examples based on remainder theorem. Okay, look at the first example. Okay, first is our very simple example. Okay, we are given any polynomial f of x is equal to x cube minus 6x square plus 2x minus 4. Okay, this is our polynomial f of x, and we have to divide this polynomial by another polynomial gx is equal to 1 minus 2x. Okay, then we have to find the remainder. Okay, this is our question. We have to find remainder. Okay, now how can we solve this question? Simply, this is the question of the remainder theorem, because here we can see we are given one polynomial and we are dividing this polynomial by other polynomial. Okay, so we have to use just simply remainder theorem. So we come to the solution of this question. Okay, how can we solve? Okay, here fx is equal to x cube minus 6x square plus 2x minus 4. We have to divide this by 1 minus 2x. So what is the remainder? For this, first of all, we put gx is equal to 0. Okay, means 1 minus 2x is equal to 0. Okay, so from here we can get x is equal to 1 by 2. So by substituting gx is equal to 0, we are getting the value x is equal to 1 by 2. Okay, now we have to find the remainder when this polynomial is divided by g of x, means we can find the value of this polynomial f of x at point x is equal to 2, means f of 1 by 2 is given by 1 by 2 cube. What I am doing? I am substituting x is equal to 1 by 2 in the place of x. So it will become 1 by 2 cube minus 6 into 1 by 2 whole square. And what is the next term? Plus 2 into 1 by 2, and the next one is minus 4. Okay, now we can solve this equation. It is, what is the 1 by 2 cube? 1 by 2 cube is equal to it will become 1 by 8 minus 6 into 4, we can write it as 3 by 2. Okay, plus 1 minus 4, take the LCM. Okay, 8 is the LCM, and what is the numbers in the numerator? 1 minus 12 plus 8 minus 32, and this is equal to minus 35 divided by 8. Okay, so this is the value of this polynomial f of x at x is equal to 1 by 2, and f of 1 by 2 is our remainder according to remainder theorem. Okay, so f of 1 by 2 is equal to minus 30 by 8. So this is our remainder. So by this way we can solve such type of problems. Okay, so it was a very simple question based on the remainder theorem. Okay, sometimes we are given some different questions. Okay, so we solve questions based on the remainder theorem. Okay, we come to our next question. Okay, what is our next question? Okay, write down the question. Okay, this is our next question. We are given one polynomial f of x. Okay, if this polynomial fx is divided by x minus 2, remainder is equal to 3. Remainder is equal to 3. What is our question? We are given a polynomial f of x. If this polynomial f of x is divided by x minus 2, remainder is 3. If the same polynomial f of x is divided by x minus 3, okay, if the same polynomial is divided by x minus 3, what is the remainder? Remainder is equal to 2. This is the condition which we are given in the question. Now we have to find the remainder when the same polynomial f of x is divided by x minus 2 into x minus 3. Okay, this is our question. We have to find the remainder. Okay, so it is a very good question. Okay, because in this question, by looking at the statements of this question, we can observe that we have to use the remainder theorem in this question, because one polynomial is divided by other polynomial. Okay, so we come to the solution of this question. Okay, by observing the first equation, f of x is divided by x minus 2, the remainder is 3. What is the condition? By using the remainder theorem, we can write down using the remainder theorem, if f of x is divided by x minus 2, then by remainder theorem we can write f of 2 is equal to 3. Okay, any doubt? This is very simple question, very simple equation. Okay, because we are dividing this polynomial f of x is equal to x minus 2, so we can directly write the equation f of 2 is equal to 3. Now we come to our second statement. If this same polynomial f of x is divided by x minus 3, okay, our remainder is 2, means f of 2 is equal to we are dividing this polynomial by f of x minus 3. So what is our remainder? F of 3 is equal to 2. This is our equation number 2. Okay, I have made these equations on the basis of the questions, because these informations are available in the question. So I have made two equations. Now we have to find the remainder when fx is divided by x minus 2 into x minus 3. So simply we can use the division algorithm. So what is our according to division algorithm, what is our dividend? Here fx is our dividend, because we are dividing fx. Okay, so and by what we are dividing f of x? This is x minus 2 into x minus 3. Okay, we are dividing this polynomial f of x by x minus 2 into x minus 3 into, suppose our quotient is q. Okay, q of x plus suppose I assume remainder of the form ax plus b. I don't know whether our remainder is constant or linear, so I have assumed this expression ax plus b. Okay, because we know that the degree of remainder is always less than the degree of the divisor. Okay, here the degree of the divisor is x minus 2 into x minus 3 is our divisor. So what is the degree of divisor? Degree of divisor is 2. So the degree of remainder should be 1, means it will be form of the linear. Okay, so we have write the expression ax plus b. It is a linear expression. Okay, now I apply the condition. What we are given? We are given that if in this equation I put x is equal to 2, what I am doing? I am putting x is equal to 2. So what is the value of f of 2? If I substitute x by 2, this equation becomes 0, because I substitute x is equal to 2. So this becomes 0 plus 2a plus b means, and f of 2 is equal to 3 by our equation. It is given our question. So 2a plus b is equal to 3. This is my equation number 3. Okay, any doubt? Okay, what we have done, we have just simply make the use of the conditions in division algorithm. We have put the value x is equal to 2, so that we have make this equation 2a plus b is equal to 3. Now if I put x is equal to 3, so what is the value of f of 3? F of 3 can be given by, now again this first expression will become 0 because here the factor of x minus 3 and the next term is 3a plus b. Okay, now according to question we are given f of 3 is equal to 2. So if I substitute 3a plus b is equal to 2, this is my equation number 4. Okay, now we are having two equations and two variables. Okay, we are having now what are our equations? We are having the two equations. The third equation is 2a plus b is equal to 3, and what is the next equation? This is 3a plus b is equal to 2. Okay, now by using these two equations we have to find the values of a and b, because we are having two equations and two variables, we can easily solve. Okay, now by using this, if I subtract these two equations, okay, sign will change. This is negative, this is negative, this is negative. So what is the value? Minus a is given by 1, means what is the value of a? A is equal to minus 1. Okay, so by this way we have find the value of a is equal to minus 1. If I substitute this value of a is equal to minus 1 in any of the equation, I can get the value of b. Okay, so 2 into minus 1 plus b is equal to 3. Okay, so minus 2 plus b is equal to 3. Okay, so what is the value of b? B is given by 3 plus 2, so b is equal to 5. Okay, so by this way we have find the values of a and b. So a is equal to minus 1 and b is equal to 5. So what is our remainder? We have assumed our remainder is equal to ax plus b because it was a linear expression. Okay, so what is our remainder? Remainder is equal to ax plus b, means what is the value? This is minus x plus 5. Okay, so by this way we can solve these questions which are based on the remainder theorem. Okay, what we have to do? We have to just make the use of the conditions. We have to use the make of the remainder theorem, then we can solve such questions. Okay, now we come to our next theorem, which is also very important theorem, that is our factor theorem. Okay, so our next topic is factor theorem.